Thank you for waiting it out today and coming to this talk. I'm really excited that you're all here. Today, I'm going to have a short but sweet little talk about creating the Lyft Driver app and some of the processes that we went through to get to a separate Lyft Driver app. But first, I'm going to talk a little bit about myself. My name is Ryan Tempas. I'm an Android engineer on the driver experience team at Lyft. We own the driver app and all of the different experiences that the driver has while they're using the app. So while they're in the ride flow or they're waiting to receive a ride, all of that is owned by our team. I went to Michigan State University, and before joining Lyft, I was at Microsoft for about 2 years. 1 year was spent at Windows, where I worked on the Android on Windows team, where we stood up an actual instance of the AOSP in Windows so that developers could run their Android apps natively. Unfortunately, that was canceled. And then I spent about a year on the Office team on an incubation project. And I've been at Lyft 10 months, almost 11 months now. I like beer, like most people my age. I like biking. I've been biking around Seattle a lot. I'm actually from Seattle, go figure. And I've been drawing and painting for a few years. All right, so what am I going to be talking about today? Before I get into this, I kind of wanted to see a show of hands. Who here has ridden in a ride-share car before? They've ordered a ride-share car. Cool. Who's ridden in a Lyft? Even better. Who's driven for Lyft? Oh, awesome. Okay, cool. We've got a few people. I recognize those T-shirts, though. All right, cool. So the first thing I'm actually going to be talking about is just what is the driver experience. It seems like a lot of us have taken Lyfts before, but it's definitely a different experience on the other side of things when you're part of Lyft. So what does the driver see while you're taking a ride? Secondly, I wanted to talk about why we decided to break off the driver functionality from the Lyft app into its own separate app. And there's two main reasons why we did it. One, the product side of things, and one, the engineering side of things. So I'm going to dive into both of those. And then finally, I'm going to get into kind of some nitty-gritties on how we did it, and talk about some of the general strategies that we use to do so. All right, so first, let's talk about the driver experience. When you open up the Lyft app, you've probably seen on the side menu a switch to driver or become a driver button on the bottom part of the side menu. Tapping that will take you into the driver experience, and the default portion of the driver experience we call being offline. So the driver can kind of get an idea of what kind of demand is in their area. In this case, we're a driver that is in San Francisco. And you can see that there's some demand around. These pink squares represents where people are requesting a lot of lifts and where there's a need for drivers. As you can see, there's some other things in the Chrome as well where a driver can dive into while they're offline. Once when a driver's kind of looked around, seen what there is to be seen, and they say, okay, I want to start receiving rides. They tap the Go Online button at the top. And what does that do? Well, it takes them online, and they become what we consider to be dispatchable. So Lyft can now give them rides that make sense for the driver to go pick up passengers. In this state, a driver can be sitting from 1 second to a few minutes, depending on the demand in the area. All right, so the driver's been online for a little bit, and a passenger requests a ride, and Lyft says, hey, you should go pick up this passenger. The driver actually gets a ride request. Drivers aren't forced to give rides to passengers. They actually have to accept them. And you can see that they get a little bit of information like your passenger rating, your picture, and so on and so forth. When the driver taps accept and they accept your incoming ride, they then go into a navigation experience. And currently we kick the driver off into either Google Maps or Waze. The driver can select this, and this will be their default navigation option. And so those apps will then take them to where they need to go to pick you up. Once they've gotten to your location, they tap pickup. And you've probably seen the screen on the left before when you're hopping into a Lyft. And if not, you've definitely seen the next part, which is where the driver actually navigates to where you're going. And again, that's whatever navigation option they've selected. From there, when they arrive at your location, they drop you off. And from there, they rate you. Yes, even your driver rates you. You don't just rate your drivers. And this is a great way to give them some power and some insight into passengers that behave well and not well. Fun fact, if either the driver or the passenger rates each other 3 stars, that pairing never happens again. So we make sure that rides that don't end well don't happen again. All right, I just showed you what we consider to be the golden path, what we usually see if you're just getting one classic ride. But it turns out there's a lot of functionality that we've baked into the driver app. And if you're curious about any of the stuff that you see on the screen or anything else, please come and talk to us, and we'd be more than happy to talk a little bit more about what the driver sees inside of the app. All right, so why did we decide to do this? It seems like a bear to go through and take apart these two apps, or two modes into two apps. So why did we decide to do this? Well, really, like I said before, there are two main considerations. One, the product, so what the advantages that the user gets because we've done this, and then the engineering side of things. What do us engineers at Lyft get because we've split the app off? First, I want to talk about some of the product motivations. So when Lyft started a few years ago, it was one app, and it had two modes, the passenger mode, which you've probably seen before, and then the driver mode, which you've seen today. And it was expected that drivers would become passengers and passengers would be drivers. So a passenger could easily switch over and give a couple of rides, switch back, and then maybe get a ride somewhere. And that was really cool and stuff, but what we realized moving forward as the years went on was that passengers were passengers and drivers were drivers. And this wasn't necessarily true across the entire board, but it was definitely something that was a trend that we saw happening. So most of the time, there wouldn't be a lot of connection between the two. So if you're a driver, why download all of the passenger code and all of the extra bloat there if you're not going to be using it, and vice versa? If you're just a passenger, why have all of the driver functionality baked into the app in both of your update sizes and all of that? So that was the first set of reasoning. And obviously, I'll be talking mostly about the driver app today. So from an engineering perspective, we had two main focuses, and those kind of break off into some other areas. The first is the fact that we wanted to reduce the amount of what I like to call app bloat. Just the size and different functionalities of the app, it makes it less smooth. Also, we wanted to increase the rate in which our engineers could develop and innovate on new features. This is a really big one, and this is one of the major reasons why we did this, ensuring that we had a very stable release of both passenger and driver functionalities without tripping over ourselves while we're trying to release new things. All right, so first about app bloat. The two main considerations here are the fact that we wanted to think about app size. Every update that a person downloads takes bandwidth from their cellular device. This is particularly a problem on iOS, especially with Swift, with the size that apps have gotten. It's really easy to hit that ceiling that Apple has for downloading apps via cellular. And we want to make sure that all of our users are able to get the most recent functionality as quickly as possible. Also, another huge thing is the fact that we wanted to be able to add new aggressive SDKs into the app, and into both the passenger and the driver app. But sometimes SDKs can be really expensive from a memory perspective. And so having all that extra room is a really nice thing when you're trying to incorporate a cool new driver feature or a passenger feature, and you don't have to ship it to everybody. Finally, the reduced startup time. So I mean, as everybody here knows, every millisecond counts when you're starting up an app. And if you're initializing a bunch of Dagger objects that are passenger related, and the user only ever uses driver functionality, then that's just wasted seconds off of their boot time. Secondly, we wanted to really focus on the shortness of feature development. One thing that we've noticed throughout the years is that sometimes driver features can step on passenger features' toes and vice versa. And when that happens, it's really frustrating because, again, from the product perspective, these are two very separate experiences that two separate groups of people are using. And so when bugs occur here, it's kind of it's frustrating. Secondly, we wanted to have two apps with two separate ship cycles. And this is really great because if you have a blocking bug on the passenger side, it shouldn't stop any of the shipping or any of the product lifecycle of the driver app and vice versa. Also, as you probably know, large features tend to be less stable in general. Large new features tend to be less stable in general than small new features. And we try to keep things small, but every once in a while you have a feature that needs to go in all at once, and it has a much higher chance of breaking things. And it's a lot better to just break one of the apps than both of them. The last one is probably the biggest one. We started working on this before we started splitting the app, just because of all the benefits of it. But it entirely helped us to create the separate app, and that's a bunch of different modules. Lyft is at the point now where no single engineer can really have a grasp over all of the code that's being written for the entire Lyft Android code base. And so from this, we have a bunch of experienced domain experts that have really been working in specific areas of the code. We call these obviously domain experts, and they tend to understand what's going on there the best. And so if you have somebody new to the code base that wants to change something, sometimes there are decisions that have been made historically that could get overturned by a newer person or somebody who's not as familiar with the code base. So having a lot of different modules with modular ownership means that we have people who understand what's going to happen and the impact of changes that people who are not as experienced with the code base may not realize. And of course, the whole point of this is to reduce bugs and increase our feature development. To dive into this a little bit more, I took a little GIF here of some of our modules in the app. And as you can see, there's a lot of them. At this point, we definitely have well over 80. We might even have over 100. I haven't taken an actual count yet. And each of these relates to hopefully a fine-grained feature. And each one of those features has a owners file. And in this owners file is a series of GitHub handles. So we know who owns what. And this is really important both when you're browsing the code and you're going to make a change, so you can talk about architectural decisions with an owner before you actually start diving in and making changes. But also it helps during our code review process. So this is just an example of a little bit of some of our checks that we do before you can actually push your code to master. And one of those is the owner's check. And that actually just checks against that file and make sure that that person has given you the go-ahead to merge your code. So even if you get somebody who's not necessarily an owner on that, you'll still need to make sure that you talk to an owner. And this is really handy. We've caught so many different issues before they've happened by doing this. So that's been really cool. And just to kind of continue on that, we're actually able to kind of see who owns this in the PR as well. So that's really, I think it's really cool. I think it's a huge contributor to the stability that we have at Lyft. All right, so we've gone with the why. So how did we go about doing this? That's a great question. So when I think about what we call the app split, because we really had two modes in one app and we're breaking off one of those modes into a new app, I think about a giant ball of dough. If you've ever kneaded dough before or made bread or any dough-based product, you've probably noticed that it's really difficult to pull apart exact pieces into what you want. There's always tendrils that manage to stick. And that's kind of how I viewed our unified app as well. We had some passenger functionality in there, we had some driver functionality, and then we had some shared components that each one of those depended on. And if we weren't super careful about how we started pulling these two apart, then it would be really easy to get a big tangled doughy mess on our hands. And so that it was really important to focus on small, purposeful changes that then contributed towards this larger goal. All right, so what did we actually want? We wanted two app modules, one for the driver, one for the passenger, that would then pull in all of the features and shared components necessary to run their respective apps. So the driver app module obviously will correlate to the driver app, and then the passenger app module with the passenger app. And as you can see, they're nice, neat, clean little buckets of features and modules that we have contributing towards that. Unfortunately, that's not what we had when we started. It would have been really easy to do this if we had everything nice and neatly tucked away like that. Originally what we had this one kind of large monolithic Lyft app module, and it had a lot of responsibilities, some of which made sense, like initializing the app, some of which were a little confusing that were in there, like deep links or long-running jobs that span the entire life cycle of the app. And then there were a few other things, like some Dagger initializations and things like that. But I guess before I get any further into what our architecture looked like, I kind of wanted to talk about one of the first general strategies that we had to get the driver app off of the ground. What we did was we just essentially created the same app again, but we turned off all of the driver functionality. So we actually had to go through and add some gates everywhere to make sure that in the driver app, you're positioned in the driver mode with no other options. So it looks like our finished product, what we wanted. However, it doesn't really have any of the benefits. So there's still more modularization that needed to occur, and there was still all of the passenger functionality in there, so we didn't really reduce any of the app bloat that we were talking about. But what it did give us was an avenue to start porting our drivers over and start testing some of our other things, like the release process of our alpha, beta, and production apps, as well as some of the server integration that we'd have to change because we're no longer just assuming that there's one app anymore. So that was really handy. While we were in the development process, we were able to test a bunch of things without having to just wait until we were done with this whole modularization process. All right, cool. So back to what we had. We were creating this Lyft app that had multiple modes. We had some mixed features, so that had both driver and passenger functionality. We had some passenger features, and we had some driver features, and then all of these were built on some common frameworks, our mapping framework, API layers, HTTP, some common UI components, and all these kind of fed and funneled into this app, which is, well, that's great. But there were some issues here that we were looking at when we were trying to split it. We didn't want to just pull this dough apart. There are some things in this app module that look a little suspect, like the fact that a driver app is also going to need some of these Dagger module initializations. We have long-running jobs that would probably run in both apps, and deep links, which obviously both apps are probably going to need them. So there's some suspicious stuff in there. Also, we had this confusing box that has mixed features. If we're shipping two separate apps with two separate functionalities, why would we have features that are being shipped on an app that will never be used? So there's something wrong there. And you can't tell by looking at this, but there was actually a lot of issues in some of our shared components as well. Shared sometimes maybe being in quotes because in some cases it had specific functionality for either the driver or the passenger. So we had a few different problems that we needed to work through. And as we were doing this, I saw kind of a general strategy in a couple of different areas. One thing to note is the fact that there is no catch-all for modularization. There's always going to be a specific case that you need to work at specifically. But in general, I saw three patterns arise, and I kind of wanted to point those out today. The first being reducing. We wanted to reduce our modules down to contain just what they're supposed to do. If a ride request module does anything else besides ride requests, we needed to rip out everything out from that and have it just do ride requests. Reuse. We wanted to reuse modules that make sense. This is, again, those core modules that had some suspicious things in them that didn't really make any difference in the general point of view. So we needed to rip out the specific implementations of different features and move them to where it made sense. And finally, recycling. So I always think of recycling like you have a giant thing and you're melting it down and having a bunch of other things out of it. That's kind of what we had to do with our main app module. There was a lot of instances where there was functionality that the driver app would need, and there'd be some strange things happening if we didn't do something about that. All right, so first, reduce. We want to reduce modules to contain more fine-grained responsibilities. Uh-oh, got a meeting. Where am I here? There we go. Cool, I'll have to skip that today. All right, so for this, I wanted to kind of call out our settings. So we've got, I've got the driver and the passenger settings up next to each other. And although it's the same sort of thing, so they're both settings, you know, what you would expect, I see some common components and I see some non-common components in here. As you can see, there's a profile picture, so there's something to do with a profile. There's an email icon, so I'm assuming that you can edit email or something like that. But then in the driver side of things, we have navigation settings. A passenger is not going to be navigating. That's why you're calling a Lyft. So we don't need to have that in the passenger app. And then likewise, on the passenger side of things, I see a business profile, which is really handy if you're going on a business trip and taking Lyfts around on your company's dime. But that's not something that a driver really needs to worry about. And so I see some interesting patterns arising from this. But first, I kind of wanted to go into what the box looks like. So we've got as you can see, some of the functionality that I was talking about: email, phone, navigation, business profile. And so what we did was said, okay, let's take out all of the stuff that makes sense for both apps, like editing email, phone number, and a few other things. And then let's make two separate modules for the things that make sense for each of the respective apps, so the driver and the passenger side of things. And that's really cool because then at that point you're not shipping driver features in the passenger app and vice versa. So that's just dandy. We rinsed and repeated for a few different things. Help was almost the exact same thing. So we had a help module that had essentially if statements determining which help things to show. Sometimes in our APIs we'd make assumptions based on what app was or what mode was currently being used, and then some of our common UI components. And the list went on. There was definitely a good chunk of things that we had to do this with. Also reusing. Okay, so we need to take these core modules and make them actually core and not have specific functionality in them. So we had a section of the app that kind of looked like this. We had a core module that had some ride request classes in it, and there was other functionality there that driver modules relied on. And it's a little strange because the driver app doesn't care about ride requests. We care about rides coming in that we actually then accept. So requesting a ride doesn't really make a lot of sense to ship in the driver app. So there's objects being initialized, there's code bloat, and who knows what else in this module that we don't care about on the driver side of things. So it makes sense, though, however, that there was already a ride request module. So why not move all the ride request stuff right over into the ride request module? So that's what we did. And from there, in this talk, I generally talk about how we have the core modules then contributing to the feature modules. However, feature modules can also take dependencies on each other. So if there's, say, a passenger feature that was taking on this core module, just for those ride request classes, we then needed to kind of change around some of the dependencies, remove that core module from that passenger feature, and then have that passenger feature rely on the ride request module instead. Different permutations like this were done in a few different areas in the app. Some common frameworks, a lot of different business logic, our maps, and there are a few other areas where this is the case as well. All right, so we've talked about reducing, we've talked about reusing, let's talk about recycling. And so this is kind of the idea that we're melting down one large module into functionality that makes sense to spread out into other modules. And the one in question here is the Lyft app module. So this big behemoth that does some things like initialization of the app that makes sense, and then other things that it's kind of a question, kind of like deep links. Because deep links are something that you really want to have in a common area that both apps could use. For those of you who don't know what deep links are, I kind of want to just brush up on that. And that's basically a routing mechanism that allows the user to jump specifically to a specific part in the code or a specific feature. And this is really handy because we could send a user a text message and then have them click on a link and have them jump right into the app at a specific part, which is pretty cool. And we use it all the time in a bunch of our passenger and driver communication. So it's definitely a really handy thing for both the passenger and driver app. However, if it's inside of the passenger app module, then that means that the driver app would have to depend on it, which just really doesn't make a lot of sense to me in general. And so we needed to do something about that. So what did we do? So we had this giant big deep links blob full of functionality taking users to specific parts of the app. And we had a bunch of feature modules that owned those specific parts of the app. So it makes a lot of sense if you have a settings deep link, maybe to move that settings logic into the settings feature module. Or if you have feature foo and you have screen foo that the deep link takes you to, it makes sense to take the user into that specific portion with a deep link owned by that module, and so on and so forth. We have probably a few dozen deep links, so this is a lot of fun to kind of finagle around with a bunch of different dependencies to get this all sorted out. But in the end, we were able to have both of these app modules sit on top of this spread out dependency graph, which then means that we can take what we want without having to take large swaths of other things on as dependencies. And we did this, two of the main areas that we did this in were long-running jobs. So again, jobs that are running in the background during the entire app lifecycle. And then also some of our Dagger modules. That was an interesting one. Okay, so what did we end up with? Well, it wasn't quite this. We're still in the process of working. I think it was probably 3 or 4 weeks ago that we actually shipped our first version of the passenger app that didn't have any driver code in it whatsoever, which is pretty cool. So that means that we're officially split away from all the problems that are associated with having these two features interact. However, modularization is something that happens every day. We're still decompiling some monolithic modules, and it's something that we'll definitely still be working on in the future. But we're definitely well on our way there. As I said, it was a short talk. Thank you very much for coming. If you have any questions, I'd love to answer some. Oh, thank you.